All right, hello and welcome. Today we're going to pull back the curtain on one of the most powerful technologies out there right now, large language models. You know, LLMs. You've definitely heard the names, GPT, Gemini, LaMDA. But what in the world are they and how do they actually work? Let's dive in.
And look, the ambition here is just massive. This quote really says it all. We're not just talking about some clever little app on your phone. Nope, we're talking about a fundamental shift in how we create, how we communicate, and how we solve problems.
So, to really get a grip on that potential, we've got to start with the absolute basics. What is a language model at its very core?
I mean, it really does feel like magic, doesn't it? You ask an AI to whip up a poem about your cat or, I don't know, explain quantum physics, and it just does it. It feels like it understands. But what's really going on under the hood is both way simpler and, honestly, even more incredible.
And here's the secret. At its heart, a large language model is basically a prediction engine. Seriously, think of it as the most powerful autocomplete you've ever seen. It has scanned trillions of words, from books, from articles, from websites, all to get ridiculously good at one single thing, guessing the next most likely word. The poetry, the computer code, the scientific breakdowns, all of that amazing stuff emerges from that one powerful skill.
But just being a good guesser wasn't enough. For decades, language models were, well, they weren't great. So what changed? What was the breakthrough? Okay, let's go check out the engine room of modern AI. So, before 2017, the models they were using, things like recurrent neural networks, or RNNs, they had to read text one word at a time, in order. It was super slow, and they had a terrible memory. They'd forget the beginning of a sentence by the time they got to the end. The transformer architecture? Total game changer. It processes all the words at the same time, in parallel. This made training way, way faster, and this is the key part. It gave the model a powerful new way to understand context over long stretches of text. So how does it handle that context? Well, this very simple sentence actually holds the secret to the transformer's power.
For you and me, this is a no-brainer. Of course the tree isn't thirsty, but a computer doesn't know that. It needs a special trick to figure out that the word it is connected to the word tiger, even though there are a bunch of other words sitting in between them.
And that trick is called self-attention. Here's a really easy way to think about it. The word it basically sends out a question, a query, asking, hey, who am I talking about here? Every other word in the sentence has a key, kind of like a name tag, and the word tiger has a key that's a perfect match for that query. As soon as that connection is made, the model grabs the value, the meaning of tiger, and links it to it. It does this for every word, creating this incredibly rich map of how everything relates to everything else.
Okay, so once the transformer engine was built, the race was on. Researchers realized this new design could be scaled up like nothing before, and it kicked off this period of just absolutely explosive growth.
And you can just see the acceleration on this timeline. Just 3 years after the Transformer paper, GPT-3 came out and just completely stunned everybody. Then you get this huge insight from a paper called Chinchilla that kind of changed the strategy. And right after that, you see multimodal models like Gemini, which can understand not just text, but images, audio, and video too. And to put that growth into perspective, the number of parameters in a model is kind of a rough way to measure its complexity. Between GPT-1 and GPT-3, just 2 years apart, the model size jumped by over 1,500 times. That ridiculous scale is what unlocked so many of the abilities we see today.
But then a really critical discovery was made. The thinking for a while was just bigger is always better. But then researchers trained 2 different models. Gopher was massive. Chinchilla was 4 times smaller, but, and this is the important part, it was trained on way more data. And guess what? The little Chinchilla model actually beat the giant Gopher model. The lesson was crystal clear. It's not just about the size of the engine, it's also about the quality and the quantity of the fuel.
So, now we have these incredibly powerful models that have read a huge chunk of the entire internet. But that's not the end of the story. You know, raw knowledge isn't the same thing as being helpful or even safe. The next step is all about refinement. This usually happens in 2 big stages. Pre-training is kind of like going to a library and just reading every single book to build up a giant base of general knowledge. Fine-tuning, on the other hand, is like taking a specialized class. The model studies a hand-picked set of high-quality examples to learn how to apply all that knowledge to actually follow instructions and have a useful conversation. And one of the most important ways they do this is with a technique called RLHF. It's actually a pretty clever process. First, you have real humans rank different AI answers from best to worst.
That feedback is then used to train a second AI, a reward model, that basically learns to predict what humans will like. Then, the original LLM gets trained again to try and get the highest possible score from that reward model. This is so important. It's how we teach an AI that just predicts words to actually understand human values and try to be genuinely helpful.
Okay, so we've got the engine, we've got the scale, and we've got the alignment. But why does any of this really matter to you? Let's take a look at what these models can actually do out in the real world. The applications are just exploding everywhere. These models can write working computer code from a simple sentence. They can provide translations that actually get the nuance right. They can summarize a 100-page report in seconds. They are the engine behind all the smart chatbots and creative tools that we're all starting to use every single day.
And just when you think you've got it pegged as a language thing, the capabilities take another massive leap forward. A system called Alpha Geometry recently took on some of the hardest high school geometry problems on the planet, and it solved 25 out of 30 of them, putting it on par with a human gold medalist. This shows a whole new level of deep logical reasoning.
And that really brings us to the final thought here. We've gone on this journey from simply predicting the next word to building systems that are capable of some seriously high-level reasoning. This isn't just a language tool anymore. It's quickly becoming a problem-solving partner. So the real question for all of us is, how are we going to guide this partnership to take on the challenges that matter most? Thanks so much for joining me.